example, this is actually taking from the TTRU3, which was launched in 2019, just to give an example of how this step-up testing method works. And by applying 100 volts step down, you would see a max deviation on one of the higher taps. Again, this is on a very big transformer of 0.51%. But if you are able to generate more voltage on the primary, like we are able to with the TTRU1 and the TTRU3, then you can see a dramatic improvement of that max deviation for that tap. And overall, the whole transformer that was measured was about 0.2%, which is a big deal improvement over that 100-volt step-down method. And with this increased excitation current resolution that we get from injecting on the secondary, because now instead of voltage, we need current, the way the transformer works. And that gives us a better way, an easier in-depth dive into that excitation current to really look for differences that when you're doing step-down measurement, you may only draw a few milliamps, where by injecting on the secondary, you're going to see that secondary current being required as part of that ratio transformation. And with those higher excitation values, it'll be easier to see when a certain phase may be having a problem. The next test that we've added into the TTRU1 is the go, no go, short circuit, open circuit, and inductance test. So if you have a turns ratio test that fails, you're going to want to understand why is it failing. And these are some typical problems that you may have where there's a short circuit in one of the windings, or there's an open circuit in another, or if the transformer was subjected to an event and now it's got a problem with the core. This go, no go test, which is a different test mode on the TTRU1 Advanced and Pro, will give you this in-depth diagnostic of the transformer. And again, it's something that can go onto a report. It can be used to explain to either your boss or to your customers that not only did we find a problem, we know exactly what that problem is, and you can make that recommendation of the maintenance strategy for that particular asset. The last testing feature that we've included in the TTRU1 is the ability to measure short circuit impedance, or otherwise known as leakage reactance. What is short circuit impedance? This is a value that's stamped on nearly every transformer nameplate as required by the standards. What it represents is a percent of primary rated voltage that would generate rated current. And so if you see a Z% of 5 and the transformer is a 100 kV transformer, that means with 5% of the rated voltage, you will get 100% of primary current. And this is typically used to influence the network that the transformer is connected to. So you'll see many different transformers with many different nameplates, impedances, depending on the core, if it's a shell type or not. And the ability to confirm the short circuit impedance of the transformer really is one of those first step diagnostics to make sure that the electromechanical integrity, the position of the windings and the core, are in the same position that they were or near to that when they were manufactured, since there is such a dependency on this impedance being correct. And what we see is that the nameplate typically specifies the nominal tap position for percent impedance. I have seen it on some transformers where the maximum and minimum taps also have percent impedance, but I would say those are less common than just seeing the nameplate impedance. You typically see it as a Z%. We have seen it as impedance percent or listed as ohms, which the TTRU1 is able to display that information, but we do default to the typical Z% that is posted on the nameplate. One important fact to note here is that the percent impedance will be temperature dependent. And on smaller dry type transformers, this may become more important. I would say the larger the transformer, the less impact temperature correction has, because the resistive component of that impedance measurement is a lot smaller in comparison to the other values. And if we look at some transformer nameplates here, in this first example, I have a dry type transformer. This happens to be a transformer with two primary tap positions. And with this means that at these different voltages, we get different impedance percents. But what we're really looking at here is the temperature rise of the instrument and what this percent impedance would be at this temperature point. So the temperature rise is always a value that goes above 20 degrees C. So you see a temperature rise of 150 is 170. And the main important point here is that you use the correct voltage to get the correct nameplate impedance percent. And you will also have to enter the kVA of the transformer in order to measure or to calculate that Z percent. This is another example on a different transformer where there's a percent impedance percent for each of those and specified at 20 MVA. And here the temperature rise is 95 degrees C. So this is what you have to look for on these types of transformers when you're evaluating the short circuit impedance value. So why do you want to do this? You want to detect deformations in windings, either due to transportation, due to faults, due to high inrush currents, if the transformer maybe wasn't demagnetized before it was put into service and drew a lot of current. That may cause a shift in the windings or the core of the transformer. And you may want to use this to determine the impedance for taps other than nominal. If you have a specific application where you want to know the exact impedance, you could use the TTRU1 for that. And this is just an example of what some transformer windings may do when they experience certain conditions out in the field due to faulting, where this sort of buckles out like this. And that's what we're looking for. The typical short circuit impedance method, how Megger did this before in the MLR10 product, we would apply a short on the secondary winding. And what was very important here was to make sure that the short was sufficiently sized and connected to that secondary winding. If you had a short that was too small, say you tried to use the same short that you use for your power factor testing, since that nameplate impedance, that 100 kV transformer that I talked about earlier, that 5%, that means only 5,000 volts to generate the full rated current. It means that that secondary winding is going to generate a significant amount of heat on a short if it's too small. So using that same short that you'd use on the power factor test set may burn up, something that I experienced myself testing in the lab when I didn't quite realize what this percent impedance value meant. So you have to make sure that it's sufficiently sized, clamped on there, screwed down with nuts and bolts. You want to make sure that the shorts are as short as possible. Those contacts, again, not only secured on there tightly, but clean and tight. You then apply AC to the primary winding. You measure the current and voltage to calculate the impedance. And then you use the primary line-to-line voltage, the kVA, MVA, to determine that percent impedance value based on the measurement. And from there, you can then compare it to the nameplate value, and it needs to be within 3% to be considered within the limits. So some of the historical challenges, this has typically required a dedicated, high current power test set. Sometimes it was an add-on to an existing power factor test set, or it was this heavy standalone instrument. And since the quality of the shorts could affect the measurements, the connections to bushings could always be questionable, and it wasn't really seen as a routine test that a lot of people wanted to perform because it was extremely difficult to get repeatable, reliable results. And that is where with the TTRU1, using the same connection that you use for turns ratio, we use internal shorting and lead compensation within the TTRU1 to give you that accurate turns ratio measurement. It's going to be the same connection as a TTR test, as I mentioned a couple times now. We're going to short that primary winding within the instrument, apply the AC to the secondary, and then we use that same calculation and comparison as the external short, doing it in the step-down method. But with that internal shorting, with that lead compensation, we're going to get you that reliability that you require, that repeatability to be able to go out and make the best informed decisions about your asset. And this is something that traditional tests with external shorts, it can be performed on this product. So if there is a question about, I don't really trust this measurement, but we really think once you get out there and you start using the product, that you will see that this ability to perform the step-up short circuit impedance with the same connection without having to disconnect leads will be your preferred method to incorporate this into your testing strategy, because we always think that with more information, you can make better informed decisions. And that's what we see in the trend of most products today, is that you will have multifunction instruments that can give you better information about your asset. So that way you can improve its longevity or start planning for its replacement if it's gone beyond a certain point. Looking now at the user interface of the product, this is what you will see when you come to the home screen. You get the ability to change voltages, you get the ability to start the test. But if we look down below, that is where you will find your different test modes or different test capabilities of the product. Of course, we have the TTR test. In the advanced and the pro model, you will have the go, no go impedance, where we're looking for the shorts, the opens, the transformer core doing its job. And then finally, the short circuit impedance measurement, where we will give you that value compared to nameplate. So for those people looking to have more information about their asset or looking to supplement power factor testing that they're doing today with an impedance test set, this will be able to perform that function for you. In the Pro and Expert, as I mentioned early on, you have the ability, or each of the models will automatically save the results. In the Pro and Expert, we give you the ability to navigate those results. And the reason why we keep that functionality separate is because some customers don't require to even have the results saved. They just want to run a test, see the ratio, and then be able to write it down on paper and move on. Other customers would like to have more control over their test data management, and that is where the Pro and Expert gives them that flexibility. Of course, there's going to be some settings on the device. You can change the brightness, you can change the date and time, the language, your measurements and limits. You can perform leads calibration if you're doing that impedance testing, typical of what you would see on most products. And then finally, you have the info screen that is used when you're talking with the factory, or if you're looking to export results or perform software updates. If we've listened to your feedback as you've gone out in the field and you've tested transformers and you see nameplates that are not within the TTRU1 today, if you can get with your Mega representative, or if you can email myself or one of the great people that we have from Mega on this call, we can work on getting that into you or getting that into the product. And then performing a software update is as easy as downloading it from our webpage, putting on a thumb drive, and then using that info screen to provide the update to the product. And we really want to listen to you when you're out there using this. So please let us know if you see something in the product that you want us to add. We're always looking for ways to improve the product for you. Looking at the turns ratio screen, here the customer entered in some information. In this example, a primary voltage, a secondary voltage. We provide the calculated ratio based on these values, the actual measured value, and then the percent error. You can also have this percent error display as a pass-fail if you would like, making it even simpler for operators to understand if something is within the limit or not without having to see that percent error. In addition, the TTRU1 will show additive or subtractive based on the transformer vector that you connected to. In the Pro and Expert model, we give you that phase deviation that you're seeing here. And again, it's based on user needs and what is part of your testing program today. Here's an example of a go-no-go impedance test where there was a short circuit applied to the high side of the transformer. We can see that the open circuit was good, the inductance test was looking good, but then the short circuit was detected. Short circuit impedance, we have a couple values that we show here. As noted in the previous section, you must enter the line-to-line voltage of the transformer, the kVA, and then finally the Z% for that comparison. You will see this result is corrected to 85 degrees C up here. Again, very important to temperature correct your percent, your Z%, especially on smaller transformers. And then if you need the detailed impedance information, that will be available here to you in this screen. By holding down the enter button for a few seconds, then it displays the actual inductance values, impedance, resistive components, what the test voltage and current was. In the results navigation for the Pro and Expert, we sort the results based on either test date or test type or percent error. This gives you the ability to go back and review results. You can export all the results from here. You can results manage and delete if you wish to. So in summary, the TTRU1, it is a single phase source and measurement device for, again, turns ratio step testing with automatic result saving, pass fail ratio evaluation, and all the models, that detailed go no go testing of a transformer, that additional nameplate verification tool of the short circuit impedance and leakage reactance, guaranteed in whatever wherever you live in the world to work and provide you those reliable, repeatable results. We give you the full color high bright display to increase your confidence that you are testing the right transformer nameplate and you are following the connections in order to get the right results. And one of the last points is that we have those AA rechargeable batteries, which will ensure that you are prepared to take on the day when you need to do your turns ratio testing. And that brings me to the end of my presentation here. And I'm going to turn it over to Grace now. And I'm sorry, it's unfortunate I won't be able to hear what's going to happen next, but I appreciate your time this morning, and I wish you all a very good week.
All right. Thank you, Ken. Thank you, everyone. So now it's come to the Q&A session. If you have any questions, please type into the question box. Our panelists and Ken will answer your questions. And for those of you who are leaving, please remember to have us fill in the survey, which you can see on the right-hand side. We'll be sending the presentation materials to those completed the survey. And you can now submit your questions in the question box.
So I see here, I'm getting a question now asking about the maximum ratio we can test with the TTRU1. Our data sheet specifies up to 50,000 to 1. In my limited field